next one, which is going to be association rule mining. So for association rule mining, here's what happens. So the initial configuration or the initial notebook that we had was based on the A rules component of the Pycaret library. But A rules is outdated and it's not available in the latest versions, and it's a bit complicated to access the older versions and make use of A rules. So for this one, initially it was France, and I used a Germany dataset, and I use instead of A rules, I'm using ML extend. So from ML extend, we are importing a priori and association rules, and we're creating a basket, and it's basically grouping data, and then the parameters that it's grouped on is invoice number and description. Then we apply the constraints for this one, and then we get the frequent item sets using a priori, and then we apply association rules, and then we want to make plots. So for ML extend, we are going to use matplotlib and cborn, and then here's the support versus lift plot right here. um, then for the last one, no, not the last one, sorry. For the next one, it's going to be binary classification. So this is pretty much the same as multi-class classification. It's just that it's going to be using two models. And the installation step and the setup step is the same. Here we are using hard disease dataset, and then we're setting it up for the functional API. The next thing we're going to do is setting it up for the object-oriented API. This is going to use classification experiment. Disease is a target column that we are going to use. So it's going to determine whether the person has a disease or not. We are comparing the models right here. So Ridge classifier is the best one we have, and then we are going to compare the models using OOP as well. So again, Ridge classifier is the best. So we're going to have a Ridge classifier as output, and you can see its configuration right here. We can analyze a model using plots like confusion matrix that we did during multi-class classification as well. Then there's feature importance plot as well, and then we can evaluate the model, and then we can see all these plots are the ones that we can create, and this is a default pipeline plot that we have. Raw data goes into simple imputer, and then again simple imputer. So this is numerical imputer, and then this is categorical imputer, and then this is clean column. I think this is categorical, and then this is a numerical. So then we are going to make the prediction on this, and then show the top half of the data or the head of the data. Uh, and then we are going to drop the disease column to make a prediction on test data. So we're going to make a prediction on the new data that doesn't have the disease column. And then we are going to further save it as a pipeline. And then here's the pipeline. So the first imputer is actually numerical, and then the second one is categorical. And then we clean the columns, and this basically the pipeline shows the previous pipeline plot that we had. Then further we have time series forecasting, right? So time series forecasting, let me go over to the very top. Okay, right here. So again, Pycaret does the install. I mean, we pip does the installation. We using the airline dataset. So I use airline because whatever dataset I was using, I was encountering a lot of errors, and what I felt like was um, maybe it's better to use airline and do the demonstration for this one. So there are two additional parameters that we add, which is the session ID and FH. And then further, what we do is we also do the API object-oriented API setup. We are using TS forecasting experiment for this one, and then we set it up and we check the stats. So what check stats does is it gets a statistics and runs statistical tests on the original data or model residuals. So once that is done, we compare the models. This is the best one we have, STLF, and then we also do it for the OOP API, and it again gives us the STLF. So we're sure that this is the most accurate model for this one. Then we plot the forecast plot, and we also do the forecast plot again by adding a few parameters. So this is going to be predicting for the future 36 months. So you add FHS 36, so it's going to predict for the 36 months in the future. Then we do residuals, and this is how it shows up. And then we do a prediction on the best model we have. And so again, we want to predict in 36 period in the future. For 36 period in the future or 36 years in future. So we add that parameter again, and we save the pipeline, and then we load it, and this is how it shows up. Then we're gonna go over univariate without exogenous, and you're gonna go to the top again. So it installs Pycaret, and then we're using NumPy and Pandas for this one, and importing the get data and TS forecasting experiment. So the data set we are using is airline, and then further what we do is we conduct a exploratory. So we want to forecast the next 12 months, right? So we do that, and then we want to have three rows of data. So that's the fold is going to be three, and then further we do exploratory analysis, which is going to be the TS forecasting experiment setup. We set it up. We set up the forecasting period, and then we set up the next thing we do is plot it. Once we plot the mode, the next thing we would do is we would plot the model adding a few constraints. So original, imputed, and transformed. And then we'll plot the ACF graph, and this is how it looks. And we do PSCF and then apply the same 36-month period, and we set the plot height as well. So the next is again a periodogram, and these are how they look. And again diagnostics, so it's mostly plotting the models in this one, and we plot the model again. So the next thing I think we are going to do is let's plot the time series decomposition next. So this is a decom graph, time series decomposition. And further what we are doing is setting, before it was 36 or 12, and this time we are setting the seasonal period to 24, and again we are doing it with a different configuration when we are drawing a STL decomposition graph as well. So again, another plot to show the time series variations, and then we run the statistical tests the options to test are summary, white noise, stationarity, ADF, KPSS, normality, and all. So this is what we do for the test summary, and then we run the stationarity test as well. So then we are going to run the white noise test, and we also do the KPSS and assign alpha value to be 0.2. And then we check the stats, check all the stats using this one command. This is the one where you don't add the parameter. And that's it for this one. We'll go on to the next one, which is a univariate with exogenous variables, univariate time forecasting with exogenous variables. So again, the setup at the initial uh, page is the same. Then we are using the air quality data set, and this one is going to show the what we are going to do is we're going to assign data target to minus 200. Then we're going to place those values, and then we're going to do exploratory analysis. This is TS forecasting experiment, and then we do the setup again, EDA setup. And so the setup mostly involves the same steps, and I think it's adding the forecasting period to be 48, and then numeric imputation target is fill, exogenous is fill. So that's basically adding the exogenous variables. And next thing we do is plot again. So this is the first plot we have, and then just mentioning the height and width of the plot. And next we are doing is making a TS plot, time series plot. So furthermore, we have what we have here is so here it's gonna plot original data with first difference order by default, and the next thing we have, do we need something? Next thing we have is again a plot model, and it's going to be a difference plot. So it's going to show all the differences in between the variations of plots here. And the finally we have the CCF plot. So it's going to plot different values across different graphs, and then we exclude And that's it for this one. This was a little hard to explain, but